Over the past 500 million years, Earth has experienced 5 mass extinctions. The most recent one, 65 million years ago, wiped out the dinosaurs due to an asteroid impact. However, the Ordovician extinction 450 million years ago has long lacked a reasonable explanation. As the first mass extinction event in Earth's history, scientists now believe it may be related to the Milky Way's habitable zone. The concept of a habitable zone is familiar to many. For instance, Earth lies within the solar system's habitable zone, where its ideal distance from the Sun allows for liquid oceans and the evolution of life. But the concept of a galactic habitable zone is relatively novel. It suggests that, just as Earth lies in the solar system's habitable zone, the Milky Way itself has a region conducive to life. Specifically, the galactic habitable zone experiences fewer supernovae compared to other regions, as frequent supernova explosions could disrupt the evolution of early life, while the Orion Arm, where our solar system resides today, rarely experiences nearby supernovae. 450 million years ago, the solar system was not in its current location. It was not even within the Milky Way's habitable zone. Thus, Ordovician life forms were likely wiped out by radiation from supernova explosions. Beyond the threat of supernovae, 450 million years ago, the solar system was also closer to the galactic center, where numerous globular clusters, dense groups of ancient stars, emitted intense radiation. Even without supernovae, Earth's spatial environment at the time was harsh and unsuitable for life evolution. From today's perspective, the Milky Way's habitable zone, like the solar system's, lies between the core and the outer boundary. At Earth's distance of 150 million kilometers from the Sun, the solar system is also 25,000 light-years from the galactic center, a distance that avoids the strong radiation of the central region, while ensuring enough nearby stars for gravitational stability. If the solar system were located in the outermost arm of the Milky Way, the galaxy's weak gravitational pull would mean even slight disturbances could send the Sun drifting into intergalactic space, becoming a rogue star, with the nearest galaxy, Andromeda, 2.54 million light-years away. A rogue sun would have no chance of fostering life on Earth, becoming a true cosmic island in the foreseeable future. Though the Sun continues its 220 million-year orbit around the galaxy, we may encounter disasters like supernovae or rogue black holes. However, if such catastrophes avoid us for the next 500 years, human civilization will likely be safe. As Liu Cixin noted, human technology grows exponentially. While our civilization spans millennia, modern technology has advanced rapidly in just over 300 years, a trend that will accelerate. Thus, technology 500 years from now is beyond our current imagination. By then, humanity may navigate freely within the solar system, or even beyond the Milky Way. Once we become a true spacefaring civilization, Earth will no longer be our only home. It will be our ancestral origin. In such a scenario, whether facing supernovae or rogue black holes, humanity would not suffer mass extinction like the past 5 events. Earth is essentially a water world, with 70% of its surface covered by oceans. Yet, compared to Earth's radius of 371 kilometers, the ocean's maximum depth of 10 kilometers is merely a thin film of water. But does the universe contain planets made entirely of water? Astronomers propose the existence of Hycean planets, a class of planets whose surfaces are covered by oceans hundreds, or even thousands of kilometers deep, with little to no land, only vast oceans and thick atmospheres. Typically, Hycean planets possess super-thick hydrogen atmospheres that trap heat and generate immense pressure, allowing liquid water to remain stable even at temperatures up to 200 degrees Celsius. On these high-pressure, water-rich worlds, the deep ocean becomes a cradle for life. As depth increases, temperatures drop, creating zones with conditions similar to Earth's oceans. At the deepest layers, massive water volumes form solid ice under low-temperature, high-pressure conditions. Beneath this ice lie the rocky metal cores of Hycean planets. Fans of Interstellar recall the first planet the crew lands on, a water world near a black hole with endless oceans and kilometer-high tsunamis. Unlike Earth, a rocky metal planet in the habitable zone, Hycean planets may not require a habitable zone to host life. Their thick atmospheres shield them from space, and their high-pressure oceans differ fundamentally from Earth's. In our solar system, Saturn's moon Titan resembles a Hycean planet with oceans and an atmosphere, despite lying outside the habitable zone. The key difference is Titan's extensive landmasses, not fully covered by liquid water. Recently, the Webb telescope discovered K2-8b, a true Hycean planet. NASA scientists speculate that primitive aquatic civilizations may exist in its deep oceans, given that Earth life originated in the oceans. Scientists estimate life on Hycean planets may share similarities, emergingly from high temperature, high pressure, impurity-rich liquid water, over vast timescales and stable environments. Perhaps, as the Webb telescope observes these worlds, massive creatures swim in their oceans. The primary limitation is that advanced civilizations are unlikely to arise underwater, without day-night cycles, and in perpetual darkness at great depths. Vision cannot evolve advanced capabilities. Moreover, the absence of mineral resources and the impossibility of smelting in oceans prevent aquatic civilizations from developing technology and venturing into space like humanity. In summary, Hycean planets represent a fascinating concept that could indeed exist in our universe. Their life forms may be beyond our current imagination or understanding, but as human technology advances and more spacecraft explore other worlds, we will inevitably encounter extraterrestrial life beings whose differences from us are unimaginable. Ultimately, all cosmic planets remind us that our understanding of the universe remains limited, with countless unknowns awaiting exploration. Amid recent global turmoil, pandemics, and wars, many have forgotten that 3 Chinese astronauts are currently working and living in the domestically built Tiangong Space Station as crew members of the Shenzhou 13 mission. Zhai Zhigang, Wang Yaping, and Yi Guangfu have spent nearly 5 months in space. They not only became the first Chinese to celebrate the Spring Festival in space, but Wang Yaping also made history as China's first female astronaut to conduct a spacewalk. For Mission Commander Zhai Zhigang, space is no mystery. During the 2008 Shenzhou 7 mission, he became China's first spacewalker, displaying the national flag outside the capsule. Due to the first-time challenges, Zhai faced false fire alarms and difficulties opening the hatch, making the mission perilous, but providing valuable experience for improving extravehicular suits. After returning to Earth, when asked about his spacewalk experience, Zhai said, "Looking down at my feet, oh my God, it's so deep, unfathomably far, I had to hold on tight. Then I saw the spacecraft suspended, and Earth suspended too, utterly unsupported. I was afraid Earth would float away." Key point: afraid Earth would float away. As we know, Earth's mass is a staggering 6 sextillion tons. Why can such a colossal object float in space? How has it orbited the Sun at 30 kilometers per second for 4.5 billion years? What force has sustained Earth's rotation and revolution for so long? Ultimately, where is the support for Earth's suspension in space? What powers its continuous motion? Why don't celestial bodies fall in the universe? Many might think the universe has no up or down, so planets simply float. But in reality, the universe does have orientation, defined by gravity. Whether Newton or Einstein both agreed that smaller masses are influenced by the gravity of larger masses falling toward them, just as everything on Earth falls toward its core. The most massive part, however, because space has almost no resistance, a smaller body's orbital speed can generate centrifugal force, balancing the larger body's gravity. For example, Earth is constantly falling toward the Sun, but at a distance of 150 million kilometers, its orbital speed of 30 kilometers per second creates centrifugal force, perfectly balancing solar gravity. Thus, Earth remains bound to the Sun, orbiting for 4.5 billion years without falling in. If Earth's orbital speed were slower, it would fall into the Sun. If faster, it would escape into interstellar space. The same principle applies to artificial satellites, orbiting Earth or eventually burning up in the atmosphere. Therefore, celestial bodies are not motionlessly suspended in space. They are perpetually falling toward more massive objects. Orbiting means falling. Artificial satellites fall toward Earth. The Moon falls toward Earth. Earth falls toward the Sun. The Sun falls toward Sagittarius, the supermassive black hole at the galactic center. The Milky Way falls toward the Virgo supercluster's center, which itself falls toward the Great Attractor. This nested, chain-like system of celestial motions forms the fundamental structure of our universe. Thus, nothing in the universe is absolutely, all bodies are in endless motion. Human perception of stillness is an illusion, as even fundamental particles never cease moving. Overall, the relationships between cosmic bodies and their underlying principles are not complex. They are magnified versions of everyday physics. This is why Newton, centuries ago, derived the law of universal gravitation from daily life and used it to predict planetary motion. In the foreseeable future, Earth will continue orbiting at 30 kilometers per second until the Sun expands into a red giant in 5 billion years, engulfing Earth and slowing its orbit, finally causing it to plunge into the solar inferno. But I believe, by that time, humanity will have long left the solar system, perhaps even the galaxy, or else been wiped out by internal wars or external disasters. The most spectacular phenomena in the universe include supernova explosions, bursts of light that outshine entire galaxies, and the nebulae they leave behind. Hubble telescope images of the Crab Nebula, Rosette Nebula, Cat's Eye Nebula, and Bubble Nebula consistently rank among its most iconic deep space portraits. To astronomers, nebulae are not only beautiful, but also cradles for new stars. Our Sun itself formed from a nebula after a supernova explosion. Among all nebula images, the most famous is the Pillars of Creation in the Eagle Nebula Serpens constellation, captured on April 1, 1995. 3 towering columns of interstellar gas pierce the cosmic void, standing with monumental grandeur against the backdrop of endless space. As a stellar nursery, it earned the name Pillars of Creation. However, recent Hubble observations suggest these 3 giant pillars, 7,000 light-years away, appear to be shrinking and risk collapse. First, let's understand the Eagle Nebula, discovered in 1945. It ranks 16th in Messier's catalog M16, located 7,000 light-years away. It resembles a soaring eagle, with wings spanning hundreds of light-years. Rich in gas and dust, it is an H2 region ionized hydrogen zone and a critical star-forming area in the Milky Way. Compared to other parts of the nebula, the Pillars of Creation have higher material density, hosting hundreds of stellar embryos. From 1995 to 2015, Hubble's 20 years of observations revealed significant changes. Gas structures at the pillars' tops are dissipating and evaporating, with a gas jet stretching 100 billion kilometers, ejected from the top, moving outward at 100 kilometers per second. This jet originates from a protostar hidden within the nebula. Astronomers estimate that within 100,000 years, stars within the pillars will fully form, and the Pillars of Creation will collapse entirely. In stellar evolution models, nebulae like the Pillars of Creation are crucial. Stars form from their hydrogen, helium, and heavy elements. Stars are born when sparse nebular material collapses. A nebula spanning light-years typically has low material density, but when triggered by nearby supernovae or gravitational influences, its material compresses. If a clump of matter gains enough mass, gravity attracts more material, forming a growing aggregate of gas and dust. Collisions heated, producing thermal radiation. An unstable protostar is born. As the core heats further, pressure rises until nuclear fusion ignites. A true star is born, depending on the nebula's mass. Stellar mass and lifespan vary. High-mass stars fuse faster, consuming fuel in millions of years, while low-mass stars can shine for billions of years. After exhausting their nuclear fuel, stars meet different fates. High-mass stars collapse into black holes, while low-mass stars undergo supernovae, returning material to the nebula, ready for the next cycle of collapse. Thus, each star formed within the Pillars of Creation depletes the nebula's mass. Eventually, when stars claim the last of the material, the pillars will collapse. This is the mission and destiny of nebulae. Though we did not witness the Sun's birth, By observing nebulae, we glimpse how it formed billions of years ago and foresee its ultimate fate.